ever pondered over the magical sequence 1, 1, 2, 3, 5, 8, and so on? This is the world of Fibonacci, an ancient mathematician who introduced this sequence to the world. The Fibonacci sequence, a series where each number is the sum of the two preceding ones, is not just a mathematical curiosity. From the spirals in sunflowers to the branching of trees, the Fibonacci sequence is deeply woven into the very fabric of nature. But who was the man behind this sequence? Leonardo of Pisa, better known as Fibonacci, was born in Italy, but his mathematical journey began in North Africa. Fibonacci's father, Guglielmo, was a diplomat representing the merchants of the Republic of Pisa in the Mediterranean port of Bougia, now Béjaïa, Algeria. It was here that Fibonacci was introduced to the mathematical systems of the East. In 1202, Fibonacci returned to Pisa and penned his famous book, Liber Abaci, which brought a revolution in the mathematical world. This was no ordinary book. It was a magnum opus that forever changed the way Europe understood and used numbers. Liber Abaci, meaning the Book of Calculation, introduced the Hindu-Arabic place-valued decimal system and the use of Arabic numerals into Europe. Until then, Europeans were still grappling with Roman numerals, a system that was cumbersome for complex calculations. But with Fibonacci's work, arithmetic became more accessible and practical. What made Liber Abaci truly groundbreaking was its introduction of the concept of place value. This system, which we take for granted today, was a novelty in Europe at the time. It allowed for the representation of large numbers using just 10 symbols, from 0 to 9. This not only simplified calculations, but also paved the way for the development of algebra and other advanced mathematical concepts. But the book did more than just introduce new numerals and a novel system. It played a crucial role in reviving ancient mathematical skills. Fibonacci, in his travels, had recognized the enormous advantages of the mathematical systems used in countries like Egypt, Syria, Greece, Sicily, and Provence. He brought these diverse strands of mathematical thought together in Liber Abaci, creating a synthesis that was greater than the sum of its parts. The book was filled with practical examples of how to use the new system in day-to-day life, from calculating profits and interest to converting weights and measures. It was through these practical applications that Fibonacci's work gained widespread recognition and acceptance. Fibonacci's Liber Abaci was not just a book, it was a catalyst for change. It was a beacon of knowledge that illuminated the path for numerous mathematical discoveries. Liber Abaci was not just a book, it was a beacon of knowledge that illuminated the path for numerous mathematical discoveries. Like all great minds, Fibonacci's intellect was not confined to a single book. Indeed, Fibonacci's contributions to the world of mathematics extended beyond the revolutionary Liber Abaci. He penned several other notable works, among them Practica Geometriae, Flos, and Liber Quadratorum. Practica Geometriae, written in 1220, is a fascinating exploration of the practical applications of geometry. This work is a testament to Fibonacci's belief in the importance of understanding the world around us through mathematical principles. In 1225, Fibonacci wrote Flos. This mathematical treatise showcases his ability to solve complex equations, demonstrating his sophistication and depth of understanding in the field. The solutions presented in Flos were far ahead of their time, reflecting Fibonacci's innovative spirit. Liber Quadratorum, on the other hand, is a unique exploration into the world of numbers. It is a book dedicated to number theory, particularly the solution of indeterminate quadratic equations. Fibonacci's method of solving these equations was so groundbreaking that it remained the most advanced solution for several centuries. However, not all of Fibonacci's works have stood the test of time. Some of his texts, unfortunately, were lost to history. Among these is De Minor Giza, his book on commercial arithmetic. This work, had it survived, would have provided invaluable insights into the mathematical practices of the commercial world during Fibonacci's time. Another significant loss is his commentary on Book X of Euclid's Elements, which offered a numerical treatment of irrational numbers. This work, contrasting Euclid's geometric approach would have been an enriching addition to the discourse on irrational numbers. The loss of these works is indeed unfortunate. They would have shed more light on Fibonacci's mathematical philosophy and the depth of his understanding. Yet even with these losses, Fibonacci's surviving works continue to inspire and influence mathematicians today. Though some of Fibonacci's works were lost in the sands of time, those that survived continue to inspire mathematicians around the globe. An enduring testament to the timeless genius of Fibonacci. Fibonacci's work was not just appreciated by the scholars of his time, but also by the common man. It's quite remarkable to think that in an era when Europe was not as invested in academic pursuits as it is today, Fibonacci's work still managed to captivate and intrigue. His mathematical prowess was undeniably sophisticated, but it wasn't just the abstract theorems that caught the public's attention. Fibonacci's work had a practicality that made it accessible and relevant to the daily lives of the people around him. His introduction of the Hindu-Arabic place-valued decimal system and the use of Arabic numerals was a game-changer for Europe. This new number system simplified commercial transactions, accounting, and bookkeeping, making it easier for merchants to conduct their business. And it wasn't just the merchants who benefited. With the new numerical system, even the average person found mathematics less intimidating and more approachable. For perhaps the first time in history, math was not just a tool for the scholars, but a friend to the common man. Fibonacci's contributions went beyond just introducing a new number system. His text played a significant role in reviving ancient mathematical skills, bringing to light knowledge that had been forgotten or ignored. His books, handwritten and carefully copied, were treasures of knowledge that inspired and educated generations of mathematicians. His contemporaries recognized Fibonacci's genius, and his work was widely appreciated. It's believed that even the Holy Roman Emperor Frederick II, a patron of the sciences, held Fibonacci in high esteem. The recognition and respect Fibonacci received during his lifetime is a testament to the significant impact he had on mathematics and society. Fibonacci was a mathematician ahead of his time, and the recognition he received was a testament to his extraordinary contributions. His legacy is not just in the Fibonacci sequence or the numbers he introduced to Europe, but in the way he made mathematics accessible and practical, a legacy that continues to inspire and influence even today. Even after centuries, Fibonacci's influence continues to resonate in various fields. Let's begin with the digital world. Today's computer algorithms often apply Fibonacci sequences. For instance, in the field of data structures, the Fibonacci heap, named after our Italian mathematician, is a data structure that makes use of Fibonacci numbers for its operations. It's a clever and efficient way of organizing and manipulating large sets of data. In the financial sector, traders and investors utilize Fibonacci retracements. This is a method of technical analysis for determining support and resistance levels in the stock market. It's based on the idea that markets will retrace a predictable portion of a move, after which they will continue to move in the original direction. The key Fibonacci ratios of 23.6%, 38.2%, and 61.8% often appear as levels of price support and resistance. But Fibonacci's influence extends beyond the world of numbers and into the natural world. In biology, Fibonacci numbers frequently appear in the arrangement of branches along the stems of plants and the arrangement of leaves along a stem. It's not just a coincidence. This pattern allows for the most efficient packing of leaves, so that each leaf gets its share of sunlight and rain. Even in the world of art, the Fibonacci sequence makes its mark. The golden ratio, which is approximately 1.618, is derived from the Fibonacci sequence and is believed to be aesthetically pleasing. Many artists and architects have proportioned their works to approximate the golden ratio, especially in the form of the golden rectangle, in which the ratio of the longer side to the shorter is the golden ratio. From the sequence of petals in a flower to the structure of galaxies, Fibonacci's legacy continues to unravel the mysteries of the universe. His work is a testament to the magic that happens when mathematics meets curiosity.